Okay, so here we have our practice of pedigrees. The very first thing that we have to do is we need to figure out which type of inheritance it is. So the rules that were on the board, I just took and I made it into a little decision tree, kind of like we had for the blood type. So the first thing we look at is, are more males affected? So remember, here, I'll write it up here. We have squares are males and circles are females. And if they are affected, they're going to be shaded in. If they are not affected, they are going to be unshaded. So here we have 1, 2, 3 females that are affected and 1 male that is unaffected. So no, there are not more males that are affected. So it tells us find 2 parents that are the same shade, but the opposite of their kid. So our first set of parents up here, they are not the same, so we cannot use them. Our second set, again, are not the same, so we cannot use them. But over here, we have 2 parents that are unshaded and 1 kid that is shaded. So it is not parents are shaded, the kid is shaded, which means that it is going to be autosomal recessive. So we're going to circle B, autosomal recessive. Whenever you are looking at 2 parents that are the same and a kid that is different, the kid is always going to be homozygous recessive, or 2 little letters, and the parents are always going to be heterozygous, or big R, little r. Now what I like to do is, no matter what the pedigree we have, our homozygous recessive ones are always going to look the same within the pedigree. So within this pedigree, because it is autosomal recessive, all of the traits that we are looking at, or all the people that have the trait we're looking at, are going to be homozygous recessive. So I'm going to go through and fill out everyone who is shaded as little r, little r. Next, I just kind of work top to bottom. So here we have someone who is unshaded, which means they have the dominant trait. So because they have the dominant trait, we know they have at least 1 big R. Now we have to look at the information around them to figure out if they have a little r or if it's a question mark if we don't know. So looking at, they have 4 kids here. They have a son and a daughter that are both little r, little r. So these guys are going to get 1 little r from their mom, and they have to get the other little r from their dad. So we know that the male up here is big R, little r. Looking at this son here, again, he is unshaded, so that we know that they have 1 big R at least. He's going to have to get his big R from his dad. So then his mom only has 2 little r's to give, so he's going to be big R, little r. Going over here, all 5 of these have the dominant trait, so they all have at least 1 big R. So I'm going to go ahead and write those out. We just have to figure out what is going to be on the next one. So we have a female, and both of her kids are dominant. They have the dominant trait. Because she does not have a child that is homozygous recessive, and we don't have any information about her parents up here, we can't tell what her other allele is going to be. So she's going to be big R, question mark. Her sons, however, are going to have to get their big R from their mom. And then if we look over here, they have to get a little r from their dad. So both of these are going to be big R, little r. And then this woman who married in over here is the same as this one. We don't have a homozygous recessive child or any information about her parents. So she is going to be big R, question mark. And this kid, the son, we cannot tell if he got a big R or a little r from either of his parents. So he is also a question mark. Now for number 2, we are going to go back to our decision tree and figure out which type of inheritance we have. So remember, squares are males, circles are females. So we have 1, 2, 3 males, 1, 2, 3, 4 females. So are more males affected? No. We are going to find two parents that are the same but are opposite of their kid. These first two parents are not the same, so we cannot use them. The second set of parents, they are the same. However, they do not have a kid that is different from them, so we cannot use them. This set of parents over here is the same, and they have a kid. They actually have two kids that are different from them, so we can use them. So we look, the parents are the ones that are shaded, so this is going to be autosomal dominant. Just like we did above, whenever we have two parents that are the same and kids that are different, we are going to label the parents as heterozygous and the kids that are different as homozygous recessive. Like I said before, everyone that is homozygous recessive in the pedigree is going to look the same. So in this pedigree, because it is an autosomal dominant trait, the recessive people, the people who have the recessive phenotype, are going to be unshaded. So you can go ahead and write in for everyone who is unshaded, little r, little r. So now that we have that, what we are going to be doing is, we'll start over here. You can start wherever you want, really. I just want to finish up this family over here. So we know that because they are shaded and it is an autosomal dominant trait, that everyone who is shaded is going to have at least one big R. So I'm actually going to go in and for everyone who is shaded, write one big R. We just have to figure out what is going to go onto their second allele. So down here, we know that they can get a big R from their mom. They can also get a big R from their dad. But no matter what parent they get that big R from, the other parent has both a big R and a little r that they could give. So both of these kids are going to be big R question mark, because we cannot tell what allele they got from their other parents. Looking up here at the top at this mother, we see that she has one big R because she is shaded. It's an autosomal dominant trait, so the dominant people are shaded. Looking at her children, she has 5 kids, 2 of them which are homozygous recessive. So they get one recessive allele from their dad, and they have to get the other recessive allele from their mom. So this mom is going to be big R, little r. This daughter down here, she's going to get her big R from her mom, which means that her dad only has little r's to give. So she is going to be big R, little r. It is going to be the same with her brother over here. Big R, little r. Our third problem. Again, we are going to go back to our decision tree. So are there more males affected than females? Here we have 1, 2, 3 males and 1 female. So yes, it is. Or yes, there are more males affected. So that means it is a sex-linked recessive trait. So we are going to circle C. So how I start sex-linked recessive traits, I like to first go through and write all of the sex chromosomes that they have. So if they are male, if they are square, they are going to have XY. If they are female, if they are circled, they are going to have XX. This just helps me so I only have to think about one thing at a time. I only have to think about either the sex chromosomes or the allele for the trait. Now the first people that I look at are the males that are shaded in. Because it is a sex-linked recessive trait, if they have the trait, they have to have the recessive allele. So any male that is shaded in is going to be X little r y. So we're going to do that for all three of these that are affected, X little r y. Any male that does not have the trait has to have the dominant allele. So they are all going to be X big R Y. And the males are going to be the easiest because you only have to worry about one allele. Now, we look to see if there are any females that are shaded in that are affected. We do have one female that is shaded in. Again, because it is a recessive trait, they need to have 2 copies of the recessive allele to show that trait. So she is going to be X little r, X little r. And then we are going to go just down the pedigree and work our way from there. So looking at her 2 daughters, we know that they have to have at least one big R because they are not shaded, and this is a recessive trait. So I'm going to go ahead and write this big R in for both of them. They are going to get the X big R. They can only get it from their dad, right? Their mom has 2 X little r's, so they can't get it from her. They have to get the X big R from their dad, which means that they have to get an X little r from their mom. So they are both going to be X big R, X little r. This woman over here who married in, we know that she has to have at least one X big R because she is not shaded in, so she has the dominant trait. However, because she does not have any children that have the recessive trait, we don't have any information about her parents above her, she's going to have to be X big R, X question mark. Again, looking at her daughters, we can see that they have the dominant trait, so they are going to be X big R. They have to get their X big R from their mom. They get their other X from their dad. And they have to get an X little r from their dad. So they are both going to be heterozygous. Then our last one here, we are not going to use our decision tree because we did make a mistake when making this. So in class, I let you guys know that this one is going to be an autosomal dominant trait. So what we are going to start off right away is looking for a set of parents that are shaded with an unshaded child. So these, we cannot use these parents because they are one unshaded, one shaded. Same here. But over here, we have a set of parents that are shaded, and they have an unshaded child. So what we are going to do is we are going to mark the parents as heterozygous and the unshaded children as homozygous recessive. Again, because this is an autosomal dominant trait, everyone who is homozygous recessive is going to be unshaded. So I'm going to go ahead and mark everyone who is unshaded as homozygous recessive. So now I'll start from top to bottom. We have a dad here. We're not going to start from top to bottom. What we're going to do is everyone who's shaded, we're going to go in and write at least one big R because we know they have at least one dominant allele because they have the dominant trait. And now we're going to start from top to bottom. So looking at the kids, they have 4 kids here. 2 with the recessive trait, 2 with the dominant trait. These 2 with the recessive trait are going to get one little r from their mom. They need to get that other little r from somewhere, though, so they are going to get that from their dad. This son over here has to get the big R from his dad. His mom only has 2 little r's to give, so he's going to be big R, little r. Over here, this woman, both of her parents are heterozygous. So because she could get the big R from either parent, and then the other parent could give her either a big R or a little r, she's going to be big R question mark. And looking at her two sons here, they have to get the big R from her. So that means their dad only has a little r to give. So that is how we work through pedigrees to determine the inheritance and the different genotypes. If you have any questions, please let me know.